AI is here with us. Encoding is probably the most obvious use case, while the rest of the world is still trying to figure out what to do with it. Using AI for coding is a no-brainer. It's like an improved version of Stack Overflow. The only question is, which AI should we use for coding? Should it be GitHub Copilot, AWS Code Whisperer, or Google Gemini? Whichever it is surely coming from one of the big players, right? What if I tell you that's not the case? At least not completely. What if I tell you that a small and relatively unknown project or a service is actually better than those big players? Today we will compare two different tools that can help us with any task related to writing or running code of any kind. Since AI tools for developers are popping like mushroom after rain, I could not compare them all, so I chose two, which I believe are representative of the current state we're in. Let's take a quick break to introduce you to Twingate, the sponsor of this video. Now, let me ask you something. Are you tired of using VPNs, but you still want to work securely? If you are, this might be the time to ditch, remove, get rid of VPNs. I mean, they're evil, right? And to switch to Twingate. It is a VPN replacement. Now, when I say VPN replacement, I don't mean the kind of VPN that allows you to watch Netflix or the kind of VPN that allows you to access your bank account. I mean the kind of VPN that allows you to access your network, your infrastructure, devices, home lab, or anything else related to your work. And the best part is that it is not a VPN. It is not one of those that end up preventing you from working or making your internet connection feel like you're using a modem from 90s. It's easy to set up and it's fast, like really fast. There is a free tier, try it out, get rid of VPNs. Thank you Twingate for sponsoring this video, and now let's go back to the main subject. In one corner we have GitHub Copilot, a tool that exists for a while now and has a big name behind it, which is pouring billions into AI. That one is heavyweight. In the other corner we have Cursor, a tool that is relatively new, a tool that hardly anyone is familiar with, and a tool which did not, at least not yet, spend billions on AI. That one belongs to the feather category. It's like David versus Goliath, except that David can use most of the tools Goliath has at its disposal. Anyways, both GitHub Copilot and Cursor serve the same purpose. Both are capable of writing code, of fixing bugs, and suggesting improvements. Both can be chat companions if you feel lonely and need someone other than your shrink to talk to. Both are working in VSCode, with GitHub Copilot being an extension, while Cursor is a special distribution of it. Both have free options, but will gladly take your money the first chance they get. You get the point, right? Both are AI-powered tools that can help with coding. Now, with that out of the way, let's get down to business and compare the two. In one corner, the one on the left side, we have GitHub Copilot. In the other corner, the one on the right side, we have Cursor. Let the battle begin. The match starts by opening main.go file and AI chats in both IDEs. Both AIs have a way to reference the whole codebase by prefixing the prompt with workspace in case of GitHub Copilot and codebase in case of Cursor. We'll use those to ask them the first question. Let's ask Copilot. Here it goes. Can you define a global variable response format that will get a value from open feature and use it to decide whether to respond to HTTP requests in JSON or text format? JSON should be the default value. Now, that does not sound like a complicated thing to do, right? It's probably just a notch above the typical Hello World example. Now, let's repeat the same question for Cursor and execute both. After a few moments, we can see that Cursor was faster to finish, while at the same time, it provided a more extensive answer. That's a plus for Cursor, right? Now, let's wait for a few more moments until Copilot finishes. When I used Copilot exclusively, I thought that it is decently fast. But now that I'm comparing it with Cursor, I must say that it is slow. I'm already growing impatient. While Copilot is working, let me stress that it does not matter that I'm using Go today. We won't go deep into it, and you should experience similar results with any other language. This comparison is about general performance and experience of using AI for coding, and my examples are there not to teach you Go, but to show you how AI can be used for coding in any language. Cursor gets a point for being faster, at least for now. Let's see what we got with Copilot first. We got a very short explanation of what it proposes we should do. That's not very helpful, right? So let's move on. Further on, it shows us what it's proposing we should do. I'm mildly disappointed that it does not somehow mark the proposed changes in the chat, and even more that it chose to show the whole code instead of the functions that should be modified. Nevertheless, this is helpful, or to be more precise, it is better than if I went to Stack Overflow or Google and asked for help. It understands the code base, or to be more precise, it knows what's in the file that is currently open, and it can propose changes. We are yet to see whether those changes are any good. Now, let's switch to Cursor. We can see right away that it structured the response differently. Instead of showing all the changes as one big code block, it split them into logical chunks. First, it tells us that we might want to add a global variable. Second, it tells us that we might want to modify the init function. Third, it suggested that we should change the HTTP error function. And then, oh boy, then we got something very interesting. Unlike Copilot that focused only on main.go, since that one was open and still is, Cursor found out that we might want to update root.go as well by proposing to change the root handler function. Even though we told both to evaluate the whole code base, Copilot focused only on the file that was open, while Cursor did what we expected from it. Further on, we got an explanation of the changes Cursor proposes, as well as the current code it referenced. The response we got from Cursor is, without doubt, better than what we got from Copilot. It is more detailed and more thought through. That's another point for Cursor. On top of that, Cursor evaluated the whole code base, while Copilot focused only on the file that was open. That's the third, I think, point I'll give to Cursor. Let's apply those changes and see how that works, starting with Copilot. It seems to be working one line at a time, line after line. So patience is required in this case. So I'm waiting and waiting and waiting. As expected from what we saw in the chat, it applied all the changes at once. We'll go through the rest of the changes Copilot proposes in a moment. For now, let's switch to Cursor and see how it handles the same block of code. Since Cursor separated each block of changes, we should apply each of them separately. I like that more. It feels more natural and safer. It's probably how I would approach it without AI. One code block at a time. Okay, so let's apply the first block of changes Cursor proposes. If we focus only on the first block of changes, we can see that both are the same. Both added a new global variable response format. Great. Visually, however, I prefer Cursor. It is easier for me to understand what changed than Copilot's approach. Cursor is cleaner and easier to understand. Copilot's use of different shades of green are confusing. Okay, now let's apply that first block of changes made by both Copilot and Cursor. Since Copilot already made changes to the whole file, we need only to tell Cursor to do the second block of changes. Now, those two proposals are different, yet both are technically correct. Subjectively, I prefer Cursor's approach, but I won't go into details explaining why it is better. It's subjective, so I'll leave that one for you to decide. Let's apply both blocks of changes and move on to the next one. The third block follows the same pattern. Copilot already implemented the changes and we need to tell Cursor to do the same. They are the same, so let's accept them and move on. Cursor has a huge advantage here, that it proposed changes to root.go as well. Copilot focused only on the file that was open, even though we told it to evaluate the whole workspace. Nevertheless, let's try something different. Let's see how those behave when we start writing code ourselves. We'll open Fibonacci.go files in both IDEs and start writing code ourselves. Right now, that function responds with text. Let's change that so that depending on the feature flag, it responds with JSON or text. We'll do that right below fib equals calculate Fibonacci number by typing if response format is JSON, and we'll press the enter key. Copilot immediately proposed the next line, which seemed to be correct. It's like it's reading my mind. Hit tab to accept the suggestion, press the enter key to move to the next line, and it immediately proposed what should be added next, the return instruction. Accept with tab, move to the next line, and it correctly proposes to close the if statement. That worked great. No complaints. At least until I find out that there is a better way to do it, if I ever find out. So let's try the same with cursor. Type if, and there's no need to finish that line. Cursor already figured out what they want to do with a single if instruction. We did not even need to type the whole line. Moreover, not only that proactively completed the first line, it proposed all the changes right away. Unlike Copilot that worked line by line, Cursor is already proposing all the changes at once. That's brilliant, and it is another point, clear point for Cursor. There is actually something else. Copilot did the bare minimum and converted my bad code into equally bad code that happened to fulfill the new requirement. Cursor, on the other hand, did an extra mile. It changed both text and JSON responses to include additional information. With its suggestions, JSON now includes the input number as well as the calculated Fibonacci number. Now, those two solutions differ in the way they implement conditionals. I could argue that what Copilot proposed is more in line with the way I would do it. Still, just as before, those are subjective differences, so I won't start nitpicking. Both are technically correct. Just as with JSON response, Cursor did the extra mile with the text response by formatting it nicely. Now, to be clear, sometimes we might not want the AI to do those additional changes, but in this case, I think it did the right thing. That's yet another point for Cursor. So far, nobody knows how many points for Cursor and none for Copilot. Cursor is winning, even though I stopped keeping track. Let's try now something different, something more radical. Having to output both JSON and text responses might not make sense. All responses should probably be JSON. So most of what we did so far might not make sense. Let's tell AI to fix that. We'll tell Copilot that I changed my mind. I want only JSON output. And then we'll let it run and do the same thing with Cursor. Just as before, Copilot keeps focusing only on the file that is currently open. So it proposed changes only to Fibonacci.go. Cursor, on the other hand, figured out that it should make changes to main.go, then to Fibonacci.go, only to go back to main.go. Cursor is clearly better, at least when figuring out what to change. Working with code is almost never limited to a single file, and the ability to understand and work on the whole code base is critical, no matter whether we're talking about humans or AI. Whomever you are, whatever you are, you work on the whole code base, not on a single file. Let's apply those changes and see whether they make sense. While Copilot made a single refactoring of the conditional it created earlier, Cursor correctly identified that feature flag we added earlier should not exist anymore. In other words, Copilot made the smallest possible change and left us with technical debt, while Cursor made the right call. If a person did what Copilot did, I would reject their PR. I'd be very disappointed that they did not do anything beyond the bare minimum or start questioning their experience. One of the two. Now, let's see whether we can talk some sense into Copilot and make it realize that it needs to do more. And this is only Copilot now. To do that, we'll let Cursor take a rest, since it already did what we wanted, and we will tell Copilot that you should have removed the change from main.go as well. This time, Copilot did the right thing and reached the same set of changes as those Cursor proposed right away. I can only conclude that Copilot needs more detailed instructions and more back and forth than Cursor. Now, that is not necessarily a bad thing. For all I know, you might be lonely and you're looking for someone to talk to rather than a tool that can help you write code. Who knows? Maybe. Now, even though Cursor did better than Copilot, I feel that both of them missed quite a few places where code makes HTTP responses. So let's ask both of them to fix it by telling them that I want that applied to all responses. With such a prompt, I'm assuming that both are aware of previous conversations, so we don't have to repeat ourselves. Now, Copilot still ignores any file that is not currently open in the editor. As a result, it failed to do anything new since it looked only at main.go and Fibonacci.go, since only those two are open in the editor. Cursor, on the other hand, understood that I want previous changes applied to all files that make HTTP responses. It found out that root.go, ping.go, memoryleak.go, on top of usual culprits, all have pieces of code that make HTTP responses. Okay, I think that's enough code for now. So far, Cursor was either just as good or better than Copilot. There's not a single case where Copilot worked better than Cursor, which is a bit surprising. One would expect Microsoft to be ahead of anyone else, at least in this game, given the investments they made in OpenAI and other projects. Now, let's check how those two compare when writing tests. Let's ask AI to write unit and integration tests. Since this time we did not specify workspace or codebase, both will work or should work on unit tests for Fibonacci.go, since that one is currently in focus. At least that's what I think should happen. Who knows? We'll see. Now, that's an interesting outcome. Even though we did not tell Cursor to write tests for the whole code base, the first suggestion it made was to generate tests for root.go, and my first reaction is to get annoyed, since I did not ask for that. However, upon a closer look, I can see that those tests are actually changes to existing tests. Since in one of the earlier iterations, it changed responses to be JSON, now it is suggesting to change tests related to those previous changes. That is actually brilliant. It's something I should have remembered to do myself. Next, Cursor suggested to create a new test file for the Fibonacci handler, the one that is currently in focus. That's the same as what Copilot did. One important difference is that when Cursor suggests to create a new file, it actually creates it. Copilot, on the other hand, does not do that. We need to create a new file ourselves first, and only then Copilot can apply code it suggests. The same is true for integration tests as well. We need to create a new file ourselves, while Cursor just creates it for us. As for the code of the tests, well, both are okay. But there is one important difference. Cursor suggested tests using the same patterns as those in existing tests. That is especially true with integration tests. Those that were created by me were sending requests to the real, whatever real means, application and using a real database. That's what Cursor did as well. I'm not sure whether it followed my patterns because it went through the code base and figured out how I like to organize and write tests, or because it simply thought that's the right way to do. I don't know why it did, but it did the right thing. That's important. In any case, we have integration tests from Cursor that are perfectly usable as they are, or with minimal changes. On the other hand, those from Copilot can be thrown to trash. Those integration tests are not any different from unit tests, and certainly did not check the existing codebase to learn how other tests are written. Now, let's talk about the rest of comparison I performed. Actually, you know what? I will spare you the details of other comparisons I performed. I'll just give you the gist of it. When I asked them for help how to do something using scripts that are in that repository, both figured out from the first attempt, the only difference being that Cursor is more detailed in its explanations. I was actually surprised that both gave me correct answers since I used nushell scripts, which are still relatively exotic, so I expected AIs not to know about them, or at least not to know enough. I was wrong. Both did well. If I would run something from a terminal, like for example those unit tests, both were fairly capable of figuring out how to relate errors pasted into the chat with the code. However, in case of Copilot, that was still limited to the code that is currently open, while Cursor never failed to evaluate the whole code base. Both failed to make any meaningful changes to my GitHub Actions workflows, which was surprising. And both suggested some decent improvements to Dockerfile, Kubernetes manifests, and other stuff that lives mostly in isolation from the rest of the code base. AI is developing fast, so any conclusions we make today might easily become invalid tomorrow. Nevertheless, there is no doubt, at least in my mind, that Cursor is a better solution than GitHub Copilot. On top of those direct comparisons, I've been using GitHub Copilot for quite a while now, probably since the first release, and I'm on Cursor for about a month now. I can safely say that right now, Cursor is better in almost every meaningful way. It is often faster, it provides more detailed explanations, it uses the whole code base as the context, thus producing better suggestions. Representation of changes in the editor are better and easier to understand. Its auto-completion is just as good or better, and so on and so forth. Now, none of those things are clear right away, but after using both for a while, Cursor is simply better in everything that matters. Those differences are sometimes small, while at other times they are significant. Some differences cannot be even qualified and fall into "this feels better" category. The only complaint I have so far is that some shortcuts are a bit messed up and in conflict with those specific to Cursor. Other than that, I can strongly recommend it. Try it out and let me know what you think. Thank you for watching. See you in the next one. Cheers.